Hi, this is Margo. This is Sunday afternoon, August the 18th, 2019, and I'm going to do a methane and Arctic sea ice update to make public on YouTube. So, hope everyone is doing well. Pardon my voice. I've had some toxic environments this week and very exhausting week, but I'm here and I want to bring the data to everyone, and I hope everyone is doing well. So we'll do the best we can to get through this. I'm going to try and make it not too long. So we have the latest methane data is from CAMS from August the 17th, from Saturday. I have the Arctic view pulled up and surface level pulled up. So this is where the methane left off on Friday. We're seeing high releases coming up now around the coastlines of the Arctic and moving out into the Arctic Ocean, and lots of high releases on land, including the Scandinavian areas. Lots of Russia is just filling up, and you'll see when we go to the North Pole view that there's China's pretty covered up with large releases, a lot of India, and so on. So the data is for Saturday. The forecast runs Sunday through Wednesday, so in the forecast we're seeing these large releases come up out of the Barents Sea here to the west of Novaya Zemlya, and then more dark red and dark releases in the Kara Sea, and then arms of methane releasing coming out into the Arctic. Now this is surface level, and so the ground is releasing all of this. It's like undulating, and waves of methane are releasing. Now the East Siberia ice shelf is right over here, and we're not seeing huge releases over here yet. They're more over further down, but you know, we've got large releases of methane, and I took the NOAA readings, and we'll look at those today too. Now let's go to the North Pole view, and from this view we can see about half the globe, the northern hemisphere. So as this plays, you can see this high release. This is Japan over here. High release coming off of Japan and out in the Pacific Ocean, and here's China and Asia, and here's India, and so on. I tried to get on the Navy website today and couldn't get on, but I saved some data from a couple of days ago from the Navy website that I will show today. I don't know if their website is just down. They might be doing maintenance on it. You know, that happens periodically, so it'll probably be back up later on. So now we'll look at the global view. We're also seeing releases of methane in the Antarctic around the coastline. Now remember, it's still winter down there, but the sun is starting to come up. I've been looking at the Antarctic on NASA Worldview, and we're able to see some things with the sea ice, and so we do have methane coming up in this Larsen ice shelf region, and also around the coastlines, and here in the Weddell Sea over here by the Pine Island Glacier. But you can see how the methane is releasing up into the Arctic now. So now we can look at a couple of different levels. The 500 HPA is about 18,000 feet. It's about halfway up in the atmosphere. So we can see it gathering over the Arctic and the higher latitudes here, and high levels gathered over India and China. And then if you look at the total column, I'm making a habit of showing total column every week now, because it's so much worse. It's exponentially worse from day to day. But look at the black over China and the Japan area, and then northern India, and then the red is moving over, now releasing or gathering over Saudi Arabia, and it's orange and going into the red over northern Africa, and it's actually going into the orangey red down here in Indonesia, and orangey in northern South America and so forth. So it's getting exponentially worse. But we do have areas that are lower, patches that are lower over here in North America, and then of course in the southern hemisphere it's lower as well. So I'm going to leave that as a backdrop. Now let's look at our NOAA data. I recorded the NOAA readings for the 477 millibar level for, let's get back to the beginning, for yesterday, for their MET-OP satellites, the MET-OP 1 and MET-OP 2, morning and afternoon, and the reading for the MET-OP 1 in the morning, the mean was 1891 parts per billion, with a big area of missing data. And the highest was 2324 parts per billion in the fuchsia colors that you can see around the globe. The MET-OP 1 afternoon reading was, the mean was 1892 parts per billion. The MET-OP 2, so that was the MET-OP 1 in the afternoon. Now the MET-OP 2 in the morning, the mean was 1868, and the MET-OP 2 in the afternoon was, the mean was 1869. So I have the spreadsheet here where I'm plotting all of this. And so here it is for the 17th. And here are all of our numbers added up and divided by 4. And the average for that level, 477 millibars, which is about 20,000 feet up, or 6,096 meters up, is 1,880 parts per billion. So that was down from last week, 0.25 parts per billion. So here's our chart, our graph over here. So here it was last week at the all-time high of 1880.25, and this week it was 1880, so it went down just slightly. But since March, since I've been tracking this, since March 1st, we're still at an increase of 22.75 parts per billion. So there's that. Now let's move on over into sea ice. Okay, I have a slideshow ready for you over here. I've been saving these the sea ice and snow cover pictures from Climate Reanalyzer every day. Here it is from today, Sunday, August 18th, and you can see the extent on the edges, and the concentration is where it's darker, that's where it's less concentrated or less thick. So I'm going to go back through the slideshow. I did an update a week ago, so we'll go back to the 11th. So we'll click back through and see how it changed over the last week. Look at this day on the 14th where these lines had melted. Now, remember we had there were explosions in Russia. They said it was from storage facilities, but I had my own theory about that. I've talked about it. But the toxic smoke that was coming out was coming right over here, and it was raining. And so I think it melted the sea ice in those lines like that. So here it is back to the last Sunday, the 11th. Here's where the sea ice was at that point. So if we click through, you can see day by day. So there's a huge decrease here from the 11th to the 12th. And then it filled back in on the 13th. Here's the 14th, 15th, 16th, 17th, and here it is today. Now here's the Navy sea ice thickness from the 16th. I had saved this, and let's blow this up a little bit so you can see. So 2 days ago, this was the sea ice thickness, and the very light lavender is just almost nothing. The white is 0, and then it goes into the blue is about one meter, and this dark aqua is about 1.5 meters, and then the aqua is about 2 meters. So this is where the old sea ice used to live, along the northern coast of Greenland and this the northern part of these Canadian islands. So we can see it's all pretty thin here and almost non-existent there, but of great interest is right here. Here's the North Pole where these two lines intersect. Of great interest is this whitish area to the east of the North Pole, large areas that are very thin. So that was 2 days ago. Here's their animation that went back 3 weeks and went forward a week, and this was from 2 days ago. So the forecast goes through the 23rd. So I'll stop it at the end of the... Here we go. So this is where they're anticipating the sea ice to be on the 23rd. With these actually going down to nothing right here by the North Pole. So hopefully that Navy website will be back up and we can be watching this. Now here's a movie that I made today, and this is from NASA Worldview. This is sea ice concentration. This is for the whole month of August, August 1st through the 16th. And this black dot is where the sun is, where it's not getting sunlight anymore. The sun has started to go back down towards the horizon as the Earth is tilting now. But it's still, the sun is still up, but it's not getting the full brunt of it. And so the melting should slow down a little bit, but we're not at the end of the melt season yet. The big melt season is over around September 17th to the 19th, but last year it kept on melting for a few weeks. So here it is from the 16th. So that was 2 days ago. So we can see the coastlines are free. The coastlines are totally free of ice now. And it's still, getting really thin. So I think that's all I had. Yeah. Now let's move on. Here's the National Snow and Ice Data Center, and here's their sea ice concentration from yesterday, and this correlates with what I showed you on NASA Worldview just now. And here's the chart with the extent. Now extent is different from volume or concentration. Extent is just how far out the ice is, even though it might be very thin or just a little skim. They count that as extent. And so this dotted line was the 2012 line that was at the lowest extent. So we had dropped below that in July, and then first part of August it looks like it's not quite as low as it was in this time in August in 2012 for the extent, but it's still very low. Here's the Greenland ice sheet today. The salmon color is where it's melting right now, and so that's slowing down a little bit, but still this is the cumulative melt days from January 1st through August 17th, and here's your chart with the white is 0, and then the blues and then it goes up to blues and orange and red and so forth. So the most melt days they've had have been on this southern western edge right along here. And here's the chart of the melt extent, and it looks like it's gone back down to kind of a normal range. For August, it went up a little bit this last week, or right there, but no more of this spiking up to 60%. So that's all of that. And on this National Snow and Ice Data Center website, they have done an analysis. They just put this up on the 15th. Here's an analysis of the Arctic sea ice, so I thought I'd go through that, and then we can look at Climate Reanalyzer real quick, and then take a peek at sea ice on NASA Worldview, and we'll wrap it up. This post is entitled Dead Heat from August 15th, 2019. At mid-month, Arctic sea ice extent is tracking close to 2012, the year with the lowest minimum in the satellite record. Sea ice volume is also tracking at low levels. Smoke from Siberian wildfires continues to cover much of the Pacific side of the Arctic Ocean, but as solar input declines this late in the melt season, it is unlikely to impact sea ice loss. Here's an overview of conditions. From August 1 to 14, sea ice extent declined at a daily rate of 91,000 square kilometers or 35,000 square miles, still above the 1981 to 2010 rate of decline of 71,000 square kilometers or 27,400. I guess they meant square miles. They said square kilometers again during this period. However, this is still below the decline of 112,000 square kilometers or 43,000 square miles per day observed in 2012. Well, let me just stop for a second. Now, there was more ice that could melt in 2012 because it was a lot thicker at that point. So, we don't have that much to melt. At the beginning of the month, the 2019 ice extent was well below 2012. Because the decline through August was slower, the 2019 and 2012 sea ice extents are now close to each other. Because 2012 is a leap year, and our tracking follows the day of the year, August 15, and 2012 is August 14 in non-leap years. The ice extent for August 14, 2019 is 5.04 million square kilometers, or 1.95 million square miles, approximately 100,000 square kilometers or 38,600 million square miles higher than for August 14th, 2012. So they're talking about extent, not thickness or volume. Sea ice retreat in the first half of August 2019 was mainly in an area of patchy sea ice in the East Siberian Sea and along the ice edge in the northern Beaufort and Chukchi seas. The northern sea route appears to be open in our satellite-based mapping, but ice may remain in some areas. The Northwest Passage is still closed. There is little change in the ice edge in the Svalbard region and northern Barents and Laptev seas. However, areas of low sea ice concentration are present along much of the remaining ice edge. So that the sea route is right here, coming from the Atlantic up here, and they say even though there's still some ice, they can get through it. There's not much that they can get through that ice and come out the Bering Strait, or they can come in this way and come around here like that. So that's the first sea route. And they've got all kinds of sea routes planned once the years go by, if we're still here, or if they're still here. As the ice continues to get smaller and smaller every year, they're planning on opening up more and more sea routes and opening up passages through. This is called the Northwest Passage, to go through these Canadian islands. A comparison of 2019 and 2012 ice extent for August 14 shows remarkable similarities. In 2012, some patchy ice remained in the East Siberian Sea. However, the ice edge in the northeastern Beaufort and northern Chukchi Seas was further north, and some larger channels in the Canadian archipelago were open. Conditions in context. Over the first half of the month, air temperatures along the Siberian coast at the 925 HPA level, about 2,500 feet above the surface, were generally 2 to 7 degrees Celsius, or 14 to 13 degrees Fahrenheit, above the 1981 to 2010 average, and 1 to 6 degrees Celsius, or 2 to 11 degrees Fahrenheit, above average over the Canadian archipelago. This was partly balanced by below-average temperatures in northern Scandinavia and the Kola Peninsula by 4 to 6 degrees Celsius, or 7 to 11 degrees Fahrenheit, a sharp counterpoint to the near-record heat of the late July European heat wave. Near-average temperatures prevailed over the central Arctic Ocean, and slightly lower than average temperatures were present along the north slope of Alaska and northwestern Canada. The atmospheric circulation was characterized by high pressure over the northern Pacific, the Aleutians, and Greenland, and by a center of low air pressure over northern European Russia. This combination drove cool Arctic air into Scandinavia and easternmost Russia. Well, it's a good thing they had cool Arctic air, because if they didn't, I don't know what the methane would have done. Huge areas of burning forests in Siberia have filled the air with smoke over much of the Pacific side of the Arctic Ocean. However, at this late stage in the melt season, with rapidly declining solar input, is unlikely to have much impact on sea ice loss. The fires are a result of the very warm and dry spring and summer conditions over the eastern Siberian Arctic, not to mention the explosions. Arctic sea ice volume, as estimated by a well-validated model produced by our colleagues at the University of Washington, is tracking at low levels as seen from satellite observations. Arctic sea ice cover is thus very thin, in addition to being very low in extent. That's what I was saying. Average Arctic sea ice thickness is estimated to be less than half of what it was at this time of year in 1980. So here's a chart. July 15th, 2019. Here's the volume, and it's at a low. It's that red line. We can see that right there. Sea ice thickness follows the change in the seasons. Early in the year, cold conditions and snowfall steadily thicken the sea ice. At the start of the melt season, typically in March, the thinner southern edges of sea ice cover melt first. Hence, the average thickness of the remaining sea ice increases, even though spring ice retreat has begun. By June, when much of the Arctic Ocean surface has reached the melting point, rapid thinning of the ice pack begins. thickness and extent both reach a minimum in September. However, even though ice extent continues to decline through August, average sea ice thickness begins to increase slightly as the thinner ice at the edge melts away. Then, after the minimum extent typically reached in mid-September, a rapid increase of sea ice extent begins, with thin sea ice covering large areas of the Arctic Ocean in a few weeks. This rapid increase of very thin ice reduces the average ice thickness, even though sea ice extent is increasing rapidly. So we talked about all this last year. Is a new record minimum possible? Okay, we're almost done. Here's the last paragraph. Here's the wrap-up. The ASENA team conducted a revised analysis of the likely course of the 2019 Arctic summer sea ice minimum using rates of loss from several recent years. While sea ice extent is now above extent for the same date in 2012, overall, our projection for the minimum is lower than estimated in our previous post. Using the average decline rate of the past 12 years from 2007 to 2018, the 2019 minimum is estimated to be 3.75 million square kilometers or 1.45 million square miles. If the 2012 decline pattern is applied from August 14th forward, sea ice reaches 3.44 million square kilometers or 1.33 million square miles. This is still above the 2012 summer minimum extent of 3.39 million square kilometers or 1.31 million square miles. However, nearly all of the recent rates of sea ice loss lead to 2019 being second lowest in ice extent, surpassing 2007 and 2016. But we don't know about the volume or the thickness yet, where that's going to end up. They just talk about the extent. So there's that. You can find that on Arctic sea ice news and analysis. Now, let's go on over to NASA Worldview and look for ourselves. Here it is from today. Let me refresh to make sure I have all the data that's in. Okay. So we're just missing right over here, but we've got everything we need. So here's Greenland. Here's Canada. Here's Novaya Zemlya. Here's Russia. You can still see the smoke coming up from Russia and coming across the Arctic. I got ahead of myself. I wanted to show Climate Reanalyzer real quick. Here's our maximum temperatures today. We can see most of the globe is in the red or the dark red, a lot of dark red. In the Arctic, this is the maximum for today. We can see that most of the Arctic is right above, still above zero. It's above freezing. Here's a little area that's not, and here's a little area that's not. Here's our 2-meter temperature anomaly. Now this is for the temperature of the air, and so we can see the Arctic is in the brown, and then parts of the Siberian coast, this is like brownish red here, and this is in the brown. This is where we saw large releases of methane coming up. And here it is around the planet, and we can see the Antarctic is in the red. So it's much warmer than normal. And we can see Canada's in the blue here, and parts of North America. Now this is because the jet stream is all messed up. but worldwide we're 0.1 degrees centigrade higher than normal. The Arctic is 1.8 degrees centigrade higher than normal. And the northern hemisphere is 0.5 degree centigrade higher than normal. Here, with our precipitation map, we can see that it's raining over the Arctic, right over the sea ice, and so that will help make that ice melt faster. And the smoke is very toxic, and so it's mixing with the rain, so it's coming down in a toxic soup, and it will make the ice melt faster. And they don't, whenever they write up these reports, they don't talk about that. So there's that. Here's the jet stream from today. It's still very convoluted and broken up. And look at it down here in the Antarctic. It's got like 3 jet streams down in the southern hemisphere. So, and we've already seen the sea ice and snow cover, and the sea surface temperature anomaly. Now this is from Thursday. That's their latest data. Now this is why it will continue to melt in the Arctic even with the sun going down, because the temperature of the ocean is so hot that it goes from the white here, like on the North Pole where it's white, it's 0, and then it goes up into the brown and into the red and to the pinky area, and that's up to 6 degrees Celsius higher than normal, and that's right here in this Chukchi Sea, in this East Siberia ice shelf. Right here, it's in the pinky zone, and then it's red all around it, and red over here in the Chukchi Sea. So most of the Chukchi Sea is red or brown, or to the pink area. Here's the Kara Sea, and the Laptev Sea. There's the Laptev Sea as well. And then here's a little bit of blue in the Barents Sea, but it's brown coming in from the Atlantic. Now look at how hot it is around Greenland. That's in the red zone and the pink zone. And then over here off the coast of North America, it's awful. The Pacific it's a mess. The Pacific is a mess right there. So the whole Arctic, the sea is just way too hot. So I don't expect much refreezing anytime soon. Okay, let's get back over here. So we'll start down here on Greenland and see what we can see. As we saw, this is ice-free, coming up through the nearest strait. These are clouds here. There's no ice through there. These are clouds here. Let's go back a couple of days, see if we can see. See, you can see it's ice-free up to here. So, go back to today. Here's Svalbard. It's ice-free. Here's Novaya Zemlya. It's ice-free. Here's the Yamal Peninsula. Ice-free. A lot of clouds. And there is rain. Now, there's a cloud over the open ocean there coming across. So here's the smoke coming over. This another weird cloud. But we can see these coastlines, they're all devoid of ice. And here's Alaska. That's all ice free. This is the Beaufort Sea here. But it's very cloudy, so it's hard to tell. Now here, where it's cloud free, you can see the condition of the sea ice where it's not concentrated at all. It's really broken up. This is getting on closer. This is at 84 degrees latitude. Now it's cloudy at the North Pole, so we can't really see what's going on ice-wise here. Here's the North Pole, so we can't really see too much of what's going on with the ice there. Here's the edge of the sea, the eastern edge here. Here it comes around. You can kind of see it through the cloud. And then here's the edge. It comes down and around and around. Where are my latitudes? Well, there it is. That got turned off. Longitude and latitude. This is helpful. This is the 80-degree north latitude. So we can see how it's melted very far in on this east side, here on the north side, and so on. Let's just, now here, you can see it's totally melted here on this northern Canadian archipelago. No ice there. And so on. Let's just, for the heck of it, turn on ice surface temperature, just to see the warmth. So that's at 270 Kelvin. So it's actually in the salt water freezes at a lower level than fresh water. So that's melting. That's above freezing. Look how warm it is over here by Svalbard. 277 Kelvin. It's very high over here. 283. This is the Kola Peninsula, I think. Yeah. Look over here by Finland. 290. Look, it's in the orange range. Here it is by Greenland. 281. Now if there are clouds, this reading doesn't show up. It's only where there are no clouds. Then over here in the Bering Strait, coming off of the Bering Strait, this is Chukchi Sea. That's 281. and so on. So we'll keep an eye on this, and I'll report as I can. Hopefully I'm going to do a weekly report to show everything. I am putting up methane videos and different things over on my Subscribestar page for my members, but I have limited time right now at this point because I'm taking care of my best friend who's like my brother, and he's been placed in hospice care, so that's taking up 24/7 of my time. So that's it's hard on me, but I want to do it. I want to be there for him, and so that's top priority. And then as I have the time and the energy, I will do updates. But the links are below, and you can sure check out this stuff for yourself. You don't have to wait for me to do a report. So I will go ahead and sign off for now, and I do think we are in the end times, and time is very short, and if you've not gotten right with God and Jesus, I recommend you do it right now. So until next time, God bless you, go in peace, and I'll talk to you soon. Good night.